Hello, everybody. Hello again. My my previous talk here, I did feature here before, and my previous talk here was related to the one I'm going to be doing today. Last time we created a GraphQL backend for the Investec API. As you know, it's well, if you were here before, we basically exposed the RESTful parts by using a GraphQL interface. And what we're going to be doing today is we're going to look at reuse that stack, but look at the developer experience on the front end and what that looks like from we're just going to put our front end developer hat on, even though I'm not fully a front end developer. I've just done some front end, but you'll see by the my design quality, this is more about the actual what it looks like to be on that side and just ask some questions there. So this is not going to be a whole application. Since this is a follow-up talk, we want to build on the GraphQL backend that I presented, but it's going to be a zoom in on specific aspects of what the front-end developer of using GraphQL is like, and looking at some of the tooling that's available, which there's lots of it. As you know, the JavaScript Node.js space is very innovative and very, let's say, there's a lot of churn, and there can be a lot of sort of hype around stuff, and it's just nice to sort of take a little bit of a like a zoom out again and just highlight, what is important and what's going to be something like basically we want to draw a level, a line, and see like a starting point of what is what are some of the features that we might look for when we approach and evaluate a front-end workflow, because not all of the workflows are created equal. You can't sort of have it all. Whatever you pick and choose, there's trade-offs wherever you go. So some provide a high level of robustness, a better feedback loop than others. Others give you a much speedier sort of get to the start, to the start line. But then, how do you iterate on that? It might be tricky to have a it might be tricky to refactor your code base, for example, especially since you've got the backend to think about as well. And we're going to look at some of that today with both of the front end and back end changing and how that looks like. So basically to sum up, I wanted to highlight what I think is going to be very important. My guess is that these will be more and more commonplace in the future, but maybe some of this tooling, I'm hoping that will be at least refreshing to some of this group. And just quickly, the tech stack that we're going to be using is React, which I think a lot of people are familiar with. But we're not going to be doing it. We're going to be looking at a functional programming language, which is actually compiled to JS. So it's a syntax that looks like JavaScript. It looks a little bit like JavaScript if you squint. It tries to be similar to JavaScript, and we're going to be compiling that into actual JavaScript. And the kind of sort of the strong sort of sell point here is that it's strongly typed, so it's solid. It's what they call a it's a robust type system, more than TypeScript. So it's got some superpowers up its sleeve. And the main thing that the editor, our editor, is going to understand our the GraphQL queries that we write. So it's going to be very the text that we paste in our GraphQL, like the text of our GraphQL query, is going to be understood by our compiler and our editor. And that's so let's dive into the demo, and hopefully I can show you some of that. So let's start with, actually, let's begin with the playground, the GraphQL Playground, which is part of the actual backend. So this is the backend that was presented, that was built and presented in my last talk. And I'm not sure who was here and who wasn't here from the audience, but we had this sort of developer UI explorer. It's kind of like a VS Code in your browser, where you're able to get code completion and get hints. If you get something wrong, you get an error, and a suggestion. You don't just say, hey, it doesn't just tell you that's wrong. It says, hey, did you maybe mean name with a small letter N? So this is kind of like, sorry, let me just bring up my notes just disappeared. Let me just bring that up. It looks like they're gone for good. Okay, so this sort of this feature that's provided on the back end for all developers to use, back end, for front end. But if a front end developer's job is to bring up a user interface, and it's got to have such and such details, the developer can come in here and basically work on the query, work out exactly what he needs. And the cool thing with GraphQL is it doesn't overfetch or underfetch. It gives you one request to do all of these that we can see here in the query. We just fire it off, and with a single HTTP request, we get what would have taken probably 3 or 4 requests in the using the RESTful API. So the first part of the the workflow would be to take this and just take the query as text and copy that into our source file. This is a plain text query that we would paste in here, and it's treated as text. Well, we paste it as text. It's not a separate GQL file. It's it's essentially, the syntax means it's a string within our whole source file that I'll show you later. When we scroll down, it has the JSX parts to it, which React developers will be familiar with.
Marcin, okay, I just want to check. So basically what the GraphQL thing does, it enables you to access the different elements of the API, but through one call.
Exactly.
But how does it actually do that? Like, so does it do multiple calls and then it combines the information into one set of data, or?
Yeah, so the GraphQL, the wrapper, the backend, actually does have to do all that work. Does have to make separate RESTful, because all we get is at the end of the day, all we get to talk to is the RESTful API. But because it's done through the backend, then we sort of abstracted away from having to work with the tiny details of that's just an implementation detail. The backend, so this was written in F#, right? But it really isn't. It's not an important part of the technical discussion. All the front end developer talks to GraphQL, and because the backend is probably on a main, like on a super high bandwidth backbone and might be a lot closer to the RESTful API, we're able to get rid of a lot of latency. So, you know, the browser having to do multiple requests could be, you know, if you're on your phone, latency is higher and you're losing a lot of sort of time. You're adding a lot of lag time to your user interactions by talking RESTful repeatedly and overfetching stuff that you don't need. And
so does it kind of fetch everything? Does it kind of fetch everything for a session, and then it's got it waiting in the front end, and then you just access it through the front end interface?
No. So the backend does the requests as like, for example, if we don't request balances, if we've deleted this balances block here, and we just said like we just want the account and the transactions, it wouldn't do that. It wouldn't fire off that RESTful request to Investec. So it does live, you know, request. It doesn't do any sort of tricky caching or anything like that. It's just that, like, let's say Investec is in AWS and this was running in AWS in the same zone. You know, geographically they would be super close, and they would probably be able to talk to each other like almost as if they were, you know, on the same server, like almost. But the latency would, like the whole lag that we would see on the front end using RESTful would go away. And taking that further, like if Investec themselves implemented GraphQL and RESTful, then, you know, it would all be done via the same server, and it would be just super efficient and super quick.
Cool.
Yeah, so I hope that like clarifies it. What we saw the errors in that playground earlier, and we can kind of get the same experience here. It's not as good, the error reporting, but pretty much, you know, it tells us what we need to know. It's like we're in our editor and we're busy. We haven't got any bindings to this. It's not like we wrote special bindings to a RESTful API, or for that matter, we have no bindings. All we have is a GraphQL client, and the GraphQL client basically it does do a prefetch of the schema. It needs to know what schema it's dealing with on the back end, but we're able to fully verify this text. So, like, you know, if I make silly mistakes in here, I don't even have to save the file. I don't know, like this shows that the file hasn't been saved yet, and yet like the query is getting full on validated within like without me having to run it or, you know, check it against any other. I don't have to run any other tooling, or worse, run my code and have to see in the browser that I have an error. I just go in here, correct it, and the highlight goes away. I know I have a valid query. And the same, you know, for any field here, let's say, you know, I thought that so we have a transaction. Let's say we had the transaction date, right? Sorry. And let's say that we want to add now, let's say that I'm convinced that it's called the effective date. Because I know that's what it was last week when it was running, and I've misspelled it and whatever. And I'm like, oh, you know, it's not there. Okay, now I've spelled it right, but it's still telling me that it doesn't know about this field. It's like, okay, you know, I need to basically go and I know straight away that my code is right or wrong without running it. Like I can go here and verify, yes, it's called posting date. You see, I don't get this level of code completion in my browser. I mean, sorry, in the browser, I get code completion in the sort of playground UI. In my VS Code, I don't really need that level. I just want to know that if this is wrong, then tell me ASAP, because I don't want to waste time and have to, do multiple alt tabs, control tabs, whatever, to find out. I want to know like immediately as I'm writing my code, and it's important to not switch context too much and stay focused on what you're doing, right? I'm sure we all agree. So what happens next is like, that's fine. This is just the query part, and we have the shape of the JSON that we're going to get back. But now this library, this GraphQL client actually goes like the next step that it does for us. The next sort of super helpful thing that it does is it generates all of the types to grab the response. So in vanilla JavaScript, you wouldn't worry about that. You would just have, say, dot whatever field and be on your way. But as you using things like TypeScript would give you a typed response for all of these, and so does this. It basically goes it parses this query, like it has to parse it already to validate it, but then it generates all of these type signatures for your this runtime that you're using. And so this being a React app, we're just going to scroll down, and we've got some annotations for React component. So I'm not sure why my scrolling is so laggy. So we have some, we've got some annotations here that this is a React component, and we're going to, the query was called get account details, and we're basically going to use a React hook for running that query. What that means for a from an API point of view, we could be in multiple states. So when the response is first like created, it's in progress. So we have a fetching state that we have to get handle. So it's like a case statement that makes sure that we handle this fetching state, and we in this while the API call is going on, we're going to display a message that we're loading your account balance. And actually, like the part here, like if we'd forgotten about this, if we just like left this out, then the whole again, the compiler tells you forgot to handle a possible case, and you need to handle this fetching case. And this is super important for, like, in dynamic languages, you often lose this well, you don't have this ability, and you often trip over yourself when you're refactoring code, and you will refactor some part of the code base and forget to change it elsewhere. This tells you that you need to handle all of these cases. First of them is fetching. So we handled that part, and we rendered an element saying, hey, we're loading your bank information, your account information. And then the next one is sort of a double. It's either we get a response with the data, or we get a partial response, which GraphQL is capable of. We don't use partial responses, but we have to handle it again. Like if we'd left this out, the partial data one, it would tell us like, hey, no, sorry, you can't, you're not allowed to give me this like incomplete declaration. So we specify it, even though our backend doesn't, we know our backend doesn't do partial responses, but it might in the future. So we need to handle that. So just like we handle a normal response, we also have a section at the bottom that handles an error. Like if the backend returns an error or an empty response,
is it just me, or did we lose?
Yeah,
Marcin?
lost the audio.
Sorry.
Marcin, you're just breaking up a bit. Mostly can't hear you.
Is this better?
Yeah, you're back.
No, I didn't realize my headphones were connected to my phone.
Oh, okay. I think you're gone again. Yeah, we can't hear you again.
It's muted.
Okay, yeah, got you.
Sorry. Okay. So we're back. So I don't know if that part is sort of clear. If we make a request and it's an AJAX, it's an asynchronous request, and it might be in multiple. It might be first it's loading, then it gets either a response or a successful response or some kind of error, and we have a sort of a case statement that makes sure that every case is handled. And again, like compiler is strict about letting us know whether our code is valid or not. Is that cool? Yeah, everybody can hear. So we're gonna go to the app, and I'm just gonna reload it so we can see it from. So this is the loading part. It takes a while, I think, because I'm on the other side of the world. Also, I'm running. I'm running this server locally. It's not like it's running in the cloud. So we've fetched the stuff and we've displayed it. We've put it, we've output that on the screen. It's not much, not much innovation has happened here, but I just want to dive into, sort of zoom in on like little bits of what we're doing. The shape of the data is exactly like we had in the query. So if our query said main account, notice here we have a query that gets the main account. That actually is fully data. Just forgive a little bit of a weird syntax here. This is changing in the next version, in the next release of this. So the developer experience is going to be improved and keep improving, but we just want to notice that like this main account is exactly what we had in the query, but we didn't have to define this as a type. Like if we just called this data.account, if we tried, it would, again, the compiler is like, no, this is not what we're expecting here. Like we don't know about an account. There is a main account, you can see. So let's do that. And diving in, like the account actually had the different fields. We were able to access the account number, account name, product name, get our balances, and then move on. And for each transaction in the response, we just map it to a row in our output using the fields that we want. We're just doing 3 fields here, just the date, and description and amount. But again, any of these are verified. So doing a stupid typo like this or trying date, it's like, no, you don't have that. You have transaction date. And notice how all the other fields from the RESTful API aren't here. We're not fetching them, and neither do we have types that are, in the RESTful world, you'd have a type, just a single type, which is always has all of the fields. Here, our type is dynamically generated. Well, it's dynamic. It's generated at compile time, but on demand according to our query. So our type only has amount, description, and transaction date, and nothing else. It doesn't have like all the weight of the, that the RESTful call has. And it is important because if you leave a dangling field behind, like for example, if you try to use posting date later on, once you've refactored your query, for example, you're not gonna basically you're not gonna trip up with your code base in one place somewhere very very distant from this file. Your compiler is going to pick it up for you and go, sorry, like fix this first, and then you can you're not done refactoring your code yet, basically, is what it's saying. And it's super valuable because it's so much quicker than going into your browser and then, you know, finding out that once you've refreshed, you hit some error. Cool. So not to bore you, we're going to try now, like we've introduced all of these fields, but let's go through adding a field looks like. So let's say our next task is, hey, you know what? We're not showing what type of account this is. We're just showing the account number. And why don't you show people that it's like, is it a savings account or a current account? So back again to this UI. Let's say, you know, I don't know what it is. Like I need to do some exploration. I need to basically, like nothing of this says account type, you know. These things are product name. We've already got that, but that's not it. We've got the name and the number. Let's try this reference name. You know, eventually we end up there, and it doesn't look like it's going to return the current account, but yes, it actually does. That's exactly what we need. So like, you know, it's not necessarily self-explanatory, the name reference name, but because we were able to explore the API so quickly, we discovered, okay, that's exactly what we need. And then we flip back into our editor, and we're able to add that reference name to the query. You know, we can add that, and now it's, you know, it type checked. So yeah, my spelling is correct. But if we didn't know if it was camel case or, you know, kebab case or whatever it's called, or a snake case, then like the hint's right there. And, you know, if we just remembered reference name, but we didn't remember exactly how it was spelled, like we're quickly able to get that right, because, you know, who uses copy and paste? So we have reference name, and it's been added to the query. And I don't know if you were watching carefully, we didn't have that as part of the data under the type that we were able to access, you know, from the response. So let's try it. Account reference name. So it took a while, but actually eventually realized, yes, that is something that I know about. Let's add a label for this, account type. Sorry, I can't actually type. So we were able to add that field pretty quickly and verify that everything is here. And in my previous talk, I said, like, if it compiles, it normally works. So we have this much better experience just interacting with our in our VS Code or whatever editor we use, and we have to go to our browser much less often, and we don't even have to refresh because that's like done for us, right? So at least we don't have to check our work as often. We're able to do these things and be a lot more confident about, you know, our level of like our level of breakage as we go through the code base and make changes. So we get a lot better sort of feedback of our how do you say, of how we affecting the quality and the state of the source tree of the code base. Ben, how are we doing for time? Do you want me to do one more use case, or do you think it would be cool to pause now and just do?
What is the other use case that you have?
So I wanted to basically go through this, just show what happens if the backend developers now decide that they want to rename these fields, because indeed, like reference name, they want to call it account type, that type of thing, and that normally causes havoc within an organization, being, you know, separate teams, and you might have different companies using this. So just wanted to show that, but
yeah,
it might
I think
be
we've got about
obvious that
5 more minutes. So if you want to, if it's only going to take 5 minutes, then
yeah,
sure.
let's try that. So like I have the backend code loaded up here, and I've commented them out because I don't want to type this. So we're just going to do renames of the fields. We've decided that number is very sort of not very descriptive, and name is not very descriptive, and reference name is not very descriptive. And we're going to rename.
Sorry, Marcin, I just wanted to, now that we are committed to only 5 more minutes, I'm going to also launch the poll.
Do it, yeah.
So,
sure.
Yeah. So the poll's about what we would like to see next in future demos of what Marcin's doing, or maybe someone else wants to start working on this project as well. And then also a bunch of you would have received the email about the Build a Plant workshop, which is just a fun thing, but who knows, maybe everyone is actually quite keen to transform to pivot to terraforming community and to dump the whole programmable banking thing. So I just threw that one in there as a fun question. But back to you, Marcin.
Okay, cool. So backend team has decided to rename fields because we haven't gone like we haven't fully launched the product. We're still busy iterating, and it's okay to make breaking changes. But now all of these front ends have to change as well. So from a front end developer's perspective, once those changes have been made, he would have to basically, when like part of the bootstrapping of the project, you check out your code from GitHub, right? You get the other developers' changes, and part of that Git pull, you'd also run a download schema from the server to get the latest schema on the GraphQL endpoint. Let's just see if .NET's just starting up there. So what we're doing here is we're just making a one-off request, and we're storing it as a file. We're storing this GraphQL schema JSON file, and that will like eventually get to our when we do the build, the continuous, like the build and watch step. When we launch that, we should be able to now tell that something's wrong with this query, that it no longer functions like the so it's still busy building. So essentially, we want to know as quickly as possible, like our CI/CD pipelines would have found this for us, but also any developer starting, firing up this project would have gone, oh, okay, like this is no longer available. What's going on? And we'd get super quick feedback about these fields. Hopefully, there would have been some communication, and we would know, like, okay, we need to basically rename these here, and we're going to be getting, we know the changes we need to make to fix them, because we've either checked in the Explorer in the playground, or we've got the email from the backend team or the comms. And here, as soon as our errors went away, we know we're confident with our query again. There's no errors here, but we can see errors in the code. So we know we're not done with the refactor yet. We need to update all of these fields as well. So that was basically my point, is that this is a full stack experience. It's not just like you coding your front end on your own, isolated. You're fully integrated with what the backend's doing as well. So that pretty much wraps it up, and I hope it wasn't too boring for everyone. I hope everybody got something out of that. I'm no longer presenting, right?
Awesome.
But
Thanks,
if you have any questions, we don't have to do them now. Whenever you want to, you can reach out. Thank you for listening, everybody.
Yeah, thanks for following up on the GraphQL thing, because it's quite cool to see it on the front end side as well, and the whole developer experience, like to see like the impact of what you built previous time on the actual end user experience. Seems quite powerful. I'm not sure, does anyone have questions about GraphQL or building stuff in this way, or any comments to add on it?
Hi, Ben. I actually have a question, if you don't mind.
Yeah.
Error handling strategy in this. What's the best practice for GraphQL? Use case. You've got one piece of information in your combined data that the user or the end user is not authorized to see. With REST, you would have been able to read the 403 or even look for null values in a combined set coming back. What's the strategy in GraphQL for handling things like that?
Sure. So there's actually two strategies with GraphQL. One is you can just return, there is a data and an error section. So your data contains your response normally, and your error is an array of errors. And you can go, normally they're just a bunch of strings. It's just error messages to the user, but you can take it as far as typing those errors. So you can actually, each one of those array elements can be a typed error. So it can contain like your user message, your error code, and whatever you decide, is important for error handling. You can even go a step further and having, like, for example, your response doesn't have to be just the data that so you could get a success or an error in your result type. So there's different ways different teams deal with it in various ways. But yeah, there's a couple of sort of strategies to make it strongly typed, like the rest of the ecosystem. So with RESTful, you would have that in the document specification for sure. And some people believe that the RESTful is already specified and that's enough. But with GraphQL, you've got the schema to sort of to define the contract, and if it's in the schema, the error will come back as you specified it in the schema. So it's up to the designer actually of the GraphQL API. Very much like RESTful is up for interpretation with many people, many different teams treat it slightly different. Even though there's purists and that saying there's only one way to do it, but I don't believe there is such a thing as a single solution in REST. I don't know, maybe there is, but I hope that answers your question. I'm not sure if is that enough.
No, it does, yes. I'll go read up a bit more about it. That's it's the only thing I was really wondering about as you were going through the demo.
Yeah, so there are fully, like, there's enums. You can specify enums for your responses. So you could have like a success of this data type and an error of all of these different enums of error, not enough, insufficient permissions, or if you do a transfer operation, which is called a mutation in GraphQL, then you could say insufficient funds as a specific error type as part of your response. It's actually really nice and really handy. We've done it for one of the neo banks in South Africa that is busy that is in development. We did a GraphQL implementation for them, and everything was sort of, all the account operations were fully typed through the GraphQL interface. And also things like logging in and verifying your, like typing in your 6-digit PIN, your OTP, for example. You can error handle on those cases, like your PIN has expired or you typed in the incorrect PIN. Those are two different enums that you're returning as an error.
Cool. Any other questions from audience?
So you mentioned that you can get partial responses. And I know you said that you're not handling them in this particular front end, but what kind of situation would lead to you getting a partial response?
So some backends have partial responses for GraphQL was a feature added on later when people realized, or when the use case became when you have something that's available quickly. For example, you have a local cache via Redis or something, and you're able to immediately return those that response. And you want to fetch some data, like for example here, transactions and account balances is another RESTful call, and we might want to do those later at a later stage. I haven't implemented that. It makes it a little bit more complex on the back end and the front end, but the use case is basically requests. Your one request might contain multiple requests, of which some are way longer than others, and you might want to basically preempt. Well, you want to optimistically just give the results that you have so that the user can see them and they can have a partial loading, partial done status on in the UI.
So just to make sure that I understand correctly, an example of that would be something like all of your account details and stuff won't change very often, so you keep that in a Redis cache, but the actual transactions need to be fetched. So you'll immediately ping back with that and then load in the transaction data as it comes in.
That's exact spot on the use case that you might want to implement this at.
Cool.
Sweet.